This question is asked us to prove this equation. First, the definition. The true stress definition is the internal load divided by the cross-section area at that point, and the engineering stress is the internal load divided by the cross-section area, the initial cross-section area. Next, we consider the volume of the object that is being stressed. The initial volume of the object should be equals to the volume after stress, because the mass doesn't change. And we can conclude that A0 L0 equal to AL. And since epsilon is the elongation strain, L should be L0 plus epsilon L0. Then we substitute it into the equation. And after arranging the equation, we get substitute it into this. And then we clearly see that the true stress is equal to the engineering stress times 1 plus epsilon.
Okay, so we are going to do the problem 2. First, we are going to draw the free body diagram of this problem. The problem wants to find the compressive stress at a cross-section located 3.0 meters below the top of the pillar of this part. So we're going to disregard this part. 3.0 meters, so 3.0 meters, and let's draw the forces. First, there are force from the sculpture at the top. Assume that this thing is the sculpture with 10,000 newtons, and there's a mg force at the cm, center of mass, and there's an internal load L. Let's say L is like this if you draw it in the original picture. So we first are going to find the mass M first. How are we going to find the mass? We call that M equals to rho V, where rho is the density and V is volume. So the problem gives sorry, you can see. The problem gives density as 2,700 kilograms per cubic meters, and V can be found from surface area multiplied by height. So surface area is like this, 0.2, and the height is 3.0 meters. Yeah, so after using a calculator, we can get this. M equals to 1,620 kilograms. So once we get M, we can use sigma F equals to MA to solve for the internal load L. We are going to use vector, and direction is denoted right here. So first we are going to get 10,000 plus mg. So we are going to use G as 9.81 for this problem. So M equals to this, G equals to 9.81, and direction and internal load L. But since it is static, this whole thing is not moving, so A equals to 0, so we are going to disregard that 0. So we can get L equals to using calculator right now. So L equals to this thing, Newton So recall that after all, we want to find the compressive stress at a cross section. So what is stress? Stress is equal to force perpendicular divided by area. Force perpendicular in this case is actually equals to L, the internal load. So yeah, it equals to this number divided by surface area of 0.2. So we are going to get 1 to 1.29 equal multiplied by 10 to the power of 5 Pascal, or equal to 129.4 kilopascal. Maybe if I use G equal to 9.80, it might give the same answer as in the worksheet. Let me try that. I think this number is quite actually, yeah, this number just maybe a G value that makes it different. So the next, they want to find the compressive strain at the same segment of this pillar. So we call that stress equal to Young modulus E multiplied by strain. So the problem gives Young modulus as 4.5 multiplied by 10 to the power of 10 Pascal. So we're just going to plug in these values. Yeah, and we are going to get strain equals to 2.87 to 10 power minus 6 meters. Yeah. So here's our answer to the two subproblems of this question. I think the value might be a bit off from the answer that you given, because maybe this G, I don't know if you use G equals to 10 or 9.8 or whatever. Yeah, thank you.
Today we are going to solve this problem. The question of this problem is to find average tensile stress and average strain of the cable, which is dB, this cable. To find tensile stress, we have to find the force that the perpendicular force acting to the cable. So to find the force, which is this force, the tension, we have to we can find tension by momentum. So by momentum we can know we have to use the perpendicular force to the grader. So we'll assume that this is the theta, and we can know that this also theta, the same theta, and then we know that the perpendicular force is t cos theta, and from the momentum is we have p times L1 plus L2 equal to t cos theta times L1, which is, yeah. So by this equation we have to substitute the P, L1, L2 and cos theta. The problem gave us P which is 32 kilonewton, and it gives L1 and L2 which is 3.0 meters and 1.5 meter respectively. So this will be 4.5 and T and cos theta, and L1 which is 3.0. We can find cos theta by Pythagoras, which is from H and L1. So H and L1 is given, then we can find the length of cable, which is dB. So H is equal to 1.6 and L1 is equal to 1.5. H square plus L1 square square root is equal to length of dB. This we can substitute H and L1. Then we'll got dB is equal to 17 by 5 meters. After that, we'll know the cos theta, which is H by dB, and cos theta is equal to H by dB equal to 1.6 by 17 by 5 equal to 8 by 17. Substitute the cos theta into this equation. We can know that T is equal to 102 kilonewton. Yeah. After that, we can find the tensile stress, average tensile stress from T, using T as a perpendicular force. So from the formula, tensile stress equal to F perpendicular by A, which is cross-sectional area. So we know that F perpendicular is T and A T by A. So it is 102 kilonewtons by A, which is 481 millimeters square. Then we got it is 212 megapascal. This is the tensile stress. After that, the second question is, what is average strain? We can find average strain by the formula. Average strain equal to delta length by initial length, which is L0, yeah. And it's the delta L is given, which is 5.1 millimeters. So we can substitute this to be 5.1 times 10 power by 3 meters, and yeah, we can find L0 or initial L, which is the length of the cable first that we have already calculated, which is 17 by 5 meters. So we can substitute it into this equation, 17 by 5 meters, and then we got tensile average strain equal to 1.5 thousand times 10 power by 6, which is here. So this is end of this problem.